YouTube for math help? ThatTutorGuy.com has videos covering everything from pre-algebra to...
But what's the point of rationalizing the denominator in the first place? If you've ever taken algebra, you've probably been taught that you have to rationalize the denominator whenever you end up with a root in the denominator of your fraction. Well, rationalize the denominator is just a fancy way of saying get the root out of the denominator. For a fraction like this one, the easiest way to do that is to multiply both the numerator and the denominator by the same root that's in the denominator. This fraction, because it has the same numerator and denominator, is equal to 1. Just like 5 over 5 equals 1, or 7 over 7 equals 1, this fraction is equal to 1 too. And multiplying something by 1 doesn't change its value, which is why we're allowed to do this. And when we do, the square root in the denominator goes away. Because when you multiply two identical square roots, you're just left with the number under the roots. And that's always true. Multiplying the square root of 7 by the square root of 7 is 7, and multiplying the square root of 2 by the square root of 2 is 2. So when we rationalize the denominator using this process, we end up with the square root of 2 over 2. And just like that, we were able to get the square root out of the denominator. But what's the point of rationalizing the denominator in the first place? Well, there are a few reasons. A simple answer is that it's easier for teachers to grade work when everyone's giving their answers in the same format. Forcing you to rationalize the denominator means that teachers don't have to look out for both 1 over root 2 and root 2 over 2 as correct answers. But more than that, our habit for rationalizing the denominator goes back to the days when we didn't have consistent access to calculators. In the same way that we always want to reduce a fraction like this to its lowest terms, before we had calculators, we wanted to do the same thing with fractions containing roots. Because doing the long division by hand for root 2 over 2 is actually a lot easier than doing the long division for 1 over root 2, and so we've agreed that square root 2 over 2 is simpler, or reduced to lower terms, than 1 over the square root of 2. And since it was easier to work with rationalized fractions before we had calculators, we've just kept that convention even though we now regularly use calculators. It's also nice to have a convention for fractions with roots so that we can easily recognize like terms. If we don't agree to rationalize denominators, we might not realize that these fractions can be added together. But if we always rationalize our denominators, this fraction transforms, and we realize suddenly that we have a common denominator, and we can add these fractions together. I'll leave it up to you to decide whether or not those are good enough reasons to keep rationalizing our denominators. But nevertheless, those are some of the reasons why we do it.
Favorite reason that she gave. But I did like her other two reasons really well. In the days before calculators, if you were trying to do a problem like this, 1 divided by square root of 2, you would go to a table and it would have a bunch of information. It would say square root of 2 is approximately this, and would have a really long decimal. It would say square root of 3 is this, and square root of 5 is this, and so forth. Now, it's easy to multiply by a number like this, but if you're trying to divide by the square root of 2, and you have this long decimal, here's how that begins. You have, so it's really this, if square root of 2 is the same as 1 point, blah, 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 all this. If you were to set that up as a division problem, it would look like this. It would be this long, crazy decimal on the outside and 1 on the inside. And do you remember what happens when you're dividing by a decimal? What do you do? How do you begin? Do you remember? What do you do with this? You move it until you get a whole number. So you move it, and then you move this one too, right? I don't know if I'm... And so what happens is now you have these two really big numbers that you're trying to do division on, and it can be hard. However, if you take this 1 over radical 2 and multiply the top and bottom by the same root that's on the bottom, do you remember what that gives us in the video? Square root of 2 over 2, okay? This thing right here, square root of 2 over 2. So those have the exact same value. They're just written differently. They're written in different forms, but they're equal to the same thing. So if I'm trying to calculate square root of 2 over 2, this is a much easier problem to begin if you're doing it by hand. Do you see how it's going to get you the same answer eventually, but it's easier for your brain to do this problem than to do this problem. And so that's reason one why this even exists in the first place, this lesson that we're going to do today. And the second reason she gave that I liked is that when you rewrite things with no radicals in the bottom, it's easier to see that they have like denominators, and once they have like denominators, you can add or subtract them, right? Because when we add fractions, they have to have common denominators. So those are a few reasons why we even have this. And the reason why I went through all this trouble to explain it to you is because this skill really does seem like one of those things that's like, why? Right? Why is this even a thing? And so that's some of the reasons. So what did you write here? The easiest way to get the root out of the denominator is to multiply both the numerator and the denominator by the same root as what? As the denominator, that's right. And the reason we can do that is because they cancel each other out. Okay. And the reason why this process is called rationalizing the denominator is because when there's a radical in the bottom, like right here, this radical square root of 2, we call that an irrational number, IRR, right? Irrational. When we rewrite it with a 2 in the bottom, we've taken this from a irrational number to a rational number, and that's why it's called rationalizing the denominator. If I have to say rationalize one more time, I might lose my mind. It feels weird after you say it so many times. So we're going from irrational to rational number, and that's why it's called rationalizing. That's what the process is called. So we're going to do a few problems, and then after this I have a practice worksheet for you. These problems on the left, we're not going to reduce anything first, just to practice the basic skill. And then these problems on the right, we will reduce first and then add the skill in. So when I'm looking at number 1 here, rad 3 over rad 2, what don't I like about how it's written right now? What don't I like about it? Like, why are we... The radical on the bottom, right? So we want to get rid of the radical on the bottom. So how do I do that? Multiply the top and bottom by the same radical. So in this case, what am I multiplying the top and bottom by? Radical 2, okay? So from our work from last week where we were multiplying radicals, we multiply all the numbers on the outside together and all the numbers on the inside together. But I don't actually have anything on the outside. I mean, technically it's 1s everywhere. But what's on the inside for the numerator? 6, right? 3 times 2 is 6. And then square root of 4 on the bottom. Which of those radicals simplifies? The bottom, right? So square root of 6 over 2. Please tell me why my answer is not the square root of 3. What mistake am I making if I say the answer is the square root of 3? No, this is a wrong answer. No, but okay, because this is a common mistake, I should have prefaced. Here's a common mistake. You tell me what the mistake is. They're simplifying the 6 and the 2, but how do I know I can't do that? What's going on? One's under the radical, and they're not the same, right? One's under the radical, and one is not under a radical. So don't try and force that right there, because your brain might see the 6 and 2 and go, 3, okay? But the 2 is outside the radical, the 6 is under, so you can't mix them up. So this is going to stay just like this. Okay. What's one way number 2 is different from number 1? It has a number on the outside, it has the 5. So how do you begin, though? The same way. Hayden, what will I be multiplying the top and the bottom by? Wait, let's go back to our notes, right here. The easiest way to get the root out of the denominator is to multiply the top and bottom by what?
6.
Yes, okay, the square root of 6, top and bottom. Take a minute and try that on your paper and see what you come up with. 5 radical 12 over radical 36, okay. What is square root of 36? 6, all right. And then there's even more work I can do still, right, on the radical 12. And so that's right, tree branch. So when you factor 12, you get 4 times 3, which is 2 times 2 times 3. And this is a square root, so I'm looking for groups of 2. So I group these 2, I bring out 1, 2. And what do I do with this 2 when I bring it out? Multiply by 5. So that is 10 radical 3 over 6. Simplify by dividing 2 on the outside, the 10 over 6. So that 10 over 6, those coefficients on the front, or those integers, or whatever vocabulary you want to call those right now. 10 divided by, you're thinking about that 10 over 6 as its own fraction and simplifying it. So it's 5 rad 3 over 3. So one thing I hope you noticed in this problem is as you're working these, your mind always has to be, bless you, thinking about where you're simplifying. The numbers on the outside as a regular fraction, can you reduce it? The numbers on the inside, can you reduce it? Does the radical need to be simplified? So there's all these moving pieces, but you have all of those skills because we've been working on them, right? All last week we were working with radicals. All right, try number 3 and see what you come up with. Krislan, what did you multiply the top and bottom by? Radical 3, right? Okay. So radical 3 along the top, radical 3 along the bottom. So the bottom is the easiest thing because something times itself with a square. The radicals cancel out, leaving you 3, right? Or maybe you wrote it as the square root of 9. The square root of 9 is 3. But I want to talk about the top for a second. Basically, when you have, so here's the thing that's going on. What's different? Have a negative 3 here with no radical on it. And then have a radical 3 here with no coefficient on it. You're really just going to smush those two together. But let me explain to you, smushing is not real math, right? Let me show you real quickly why we can just smush them together so that if you feel like you need to know the math behind it. We have negative 3 times radical 3. And I've been telling you, multiply the numbers on the outside and multiply the numbers on the inside. Well, negative 3 is just a number on the outside. There's no radical. But you can think about it as really having a radical 1 attached. Because what is the square root of 1? It's 1, right? And so then when you multiply it by the square root of 3, well, there's no number out front, but you know that it's what? 1. And so then when you now say, okay, now I'm going to multiply the numbers on the outside, negative 3 times 1. And I'm going to multiply the numbers on the inside, 1 times 3. Well, that's the same thing, right? That's smushing. So you're smushing the negative 3 and the radical just together. But really, that's the math behind it, okay? We just don't need to go through that every single time. So anytime you see a number by itself and a radical and you're multiplying, you just smush them together. You do not multiply them and stick them under the radical, which is the most common mistake here. So now I've got this. And now if you're looking at the numbers on the outside, the coefficient up here, negative 3, and the 3 in the denominator, and you do the math right here, what is negative 3 divided by 3? Negative 1, right? So you can write negative 1 radical 3. You can also just write negative radical 3. But those are equivalent values. So we smushed them on top, and then the radical canceled on the bottom, leaving me with just 3. I'm about to scroll up. Does anybody need that on the bottom anymore? Scrolling, 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 scrolling. We did not reduce first here. We could have, though, on number 2. And so we're going to do some things like that on 4 and 5. We're going to reduce first. I'm going to erase all this right here. Does anybody need this stuff that's on the right side? Okay. All right, so when I say reduce first, what I mean is think of reduce wherever you can. You can think about this kind of like we did last week when we were multiplying. I said multiply the numbers on the outside, multiply the numbers on the inside. Well, now we're just dividing the numbers on the outside, dividing the numbers on the in. We're seeing a fraction on the out, fraction on the in. So I'm going to just draw this dotted line right here so we can sort of separate it a little bit. If you're looking at the numbers on the outside, 3 over 4, how, if at all, can you simplify that fraction anymore? Can't simplify, so we're just going to leave it alone. But what about the numbers in the radicals, the 3 over 6? I can simplify that. What can you divide both of those by? By 3, right? All right, so here's how I'm going to begin this problem. Divide both of those by 3, and that gives me still the 3/4 that were the coefficients. But now under the top radical, I have 3 divided by 3, which is 1. And the bottom radical, I have 6 divided by 3, which is 2. And by the way, what is the square root of 1? 1. So this radical right here can just drop off entirely because it's 3 times 1. And what don't I like about what I have now? 3, the radical in the denominator. How do I get rid of that? What am I multiplying by radical 2? Top and bottom. Okay. So you try that on your paper. Try and finish out that problem right there. All right, so Krislan, what is my numerator going to be on the top if I'm smushing? No. Remember, we're just smushing. We're not actually doing any math. 3 radical what? If we're not 2, that's right. Okay. So when it's a number by itself and a radical by itself, you can't actually do the math on the numbers. You're just putting them next to each other, smushing them. And then on the bottom, I have 4 times these 2 radicals multiplied. 2 times 2 is 4. Megan, what is the square root of 4? 2. And what am I going to do with that 4 and that 2? Multiply. So the top cannot simplify anymore, so I have 3 rad 2 over 8. You still have to check one more thing. You have to now look at the 3 and the 8 and see if it simplifies at all, but it doesn't, so we're gold. Now, all of this that we've done, we're at the last example, the I will problem, 3 rad 8 over 6 rad 12. Tell me something you notice here. 3 and 6 can simplify. What else? 8 and 12 can simplify. So you're going to do those separately. You're looking at the coefficients by themselves. You're looking at the radicals by themselves. The numbers outside, the numbers inside. What can I divide 3 and 6 by? Okay. And what can I divide 8 and 12 by? 4. So my new problem will look like this. The numbers on the outside first give me 1 over 2. The numbers on the inside give me rad 2 over rad 3. And what don't I like about that? The radical on the bottom. So again, rinse, what is it? Wash, rinse, repeat. We multiply the top and bottom by the radical in the denominator. So that gives me radical 6 on top over 2 radical 9. Why 9? Because of the 3 times 3. What's the square root of 9? 3. And what am I going to do with this 2 and this 3? Multiply. Is there anything else that I can simplify here? No. Okay. So I have a practice sheet for you. The key is in the back. I want you to